Okay. We left off, we did 33C last week. So we're going to pick up with the rest of our examples with 39, 43, 46. We're going to do a walkthrough on 53 through 55. I'll explain that when we get to it. And then we're going to do 57, 59, 60, 61, 62. You got to make a choice, 67 or 69. We'll do 71. Then you're going to make another choice, 73 or 75. We'll do 81, and then you got to make one last choice in your 85 as your example for 1.3. You have a quiz on Thursday on 1.3. And the quiz is going to be from 2 questions from this set of problems. From numbers 31 to 65, 2 questions. So basically, we're looking at them right now. 31 to 65. Yes.
You have like a paper towel.
A paper towel.
or something.
No, you. Here, use this. My toaster from home.
No, it's okay.
No, seriously.
No, Jessica, right now, but you guys can't just throw water all over.
We believe you. Okay. So. Pick up with 9. And I'm getting so more relevant questions that pop up definitely when you see them in a calculus class. This type of function, f of x equals absolute value of x over x, happens quite a bit in a calculus class. Absolute value of x divided by x. When we discuss whether a function is continuous or discontinuous, and the different kinds of discontinuity you might encounter, and the definition of continuity of the intervals, never mind, don't worry about it. But the bottom line is you just have to substitute these values. So 39a, f of 9. So replace x with a 9. It's the absolute value of 9 divided by this x is now a 9. The absolute value of 9 is 9. 9 is 9. 9 over 9, 1. So f of 9 equals 1. And then b. What happens if you substitute negative 9 into the function? So it's the absolute value of x now becomes the absolute value of negative 9 over just x, and you substitute negative 9 in for that x. So it's the absolute value of negative 9 over negative 9. In the numerator, the absolute value of negative 9 is positive 9 over negative 9. 9 divided by negative 9, we get a negative 1. So 1, we get 1 for the first part, we get 1. On the second one, we get a negative 1. That's what t. If instead you want to replace x with a t, if we substitute t in for x, then all the x's become t's. It's now the absolute value of t divided by this x is now a t. It's now just written with respect to t instead. That's all. Okay. That's 39. 43. No, 43 down. So now we are piecewise. A piecewise function is a function written into separate pieces. And those two separate pieces have defined domains that you choose, that you plug in from. You're going to use x squared plus 2 if you're plugging in values of x that are less than or equal to a 1. And you're going to use 2 times x squared plus 2 if you're going to plug in values of x that are greater than a 1. Is this domain implied or is it explicit? Explicit. You are definitely told, here's the domain. For this one, the domain is you're only going to use these x's. Only if you have an x that's less than or equal to a 1, that's what you use here. And here, you're only going to use this one when x is greater than 1. You are told what to use, when to use it. Very explicit. When you see something explicit on TV, it's like, I too much information. I've seen enough. Too much information. That's a lot of information. Implied, they don't give you any information. You're supposed to be able to look at it and figure out by looking at it what it is. Like right here, absolute value of x over x. What can you not have in the denominator? 0. And technically, if you plug in 0, you get 0 over 0. And that's not necessarily undefined. It's indeterminate. We don't know what that is. Okay. So that's a different category, but you still can't plug 0 down here. But that's not told, that's implied. You're not given for all x is not equal to 0. You never, that's never expressly told you, explicitly told you. You're given an explicit domain, like right here. So you got to pay attention to what you're plugging in and when you're plugging it in. For A, f of -2. So over here, you go over here to these parts first, not this, but this. Is -2 less than or equal to a 1, or is it greater than a 1? I'll wait over here. It's in the less than or equal to category. So since it's in this category, you're going to plug it into this piece. So it's going to go into here. You're going to square it. Now remember, if you write this, and you get +4 plus 2, and you get 6. You're going to lose points because this does not equal +4. I'm going to be very strict about this because if this were the good old days, I would get to have like one of them pointer sticks, and I get to go around and get knuckles when you make mistakes like that, because we've got to break through the bad habits. They will bite you. Okay, that's what the nuns did to me, and look how never mind. That's what I had to do. Good old corporal punishment is what my generation grew up with. Mama dropping me off at a slumber party, telling parents, if he gets out of line, just hit him. Okay. My parents, they had the threat was, go get the stick. That means we would have to go under the sink and get this piece of floor molding, wooden floor molding, with your head. Now, my dad never did. It was always when you substitute a negative, that is +4. If you go -2 squared, that's negative, and then 2 times that's -4, not positive. Okay. So +4 plus 2, and we get 6. That's A. And B. That's 1. So is 1 less than or equal to a 1, or is 1 greater than a 1? It's got to be equals. So you only plug it into this first piece. So when we plug in 1, we're going to plug it into x squared plus 2. So 1, and why not just get used to plugging in the parentheses 1 squared plus 2? So f of 1 is equal to 1 plus 2, and f of 1 is equal to 3. I know you can do 1 squared in your head. I can do 1 squared in my head too. But I don't when I show you guys when I'm doing stuff on the board, because somebody's going to look up and go, where'd that come from? And I just tend to make less, fewer mistakes, not mistake free. Fewer mistakes if I have good habits. And then C, f of 2. So again, you go to the explicit domain. Is 2 less than or equal to 1, or does 2 belong in the x greater than 1? It's in the greater than 1, so you plug it into the second piece. So f of 2 is going to go in here, and you have a 2 in front, and then you have 2 squared, and then you have a plus 2. Order of operations. Before you can multiply, you have to do that exponent. So this f of 2 is equal to 2 times, that's 4, and then plus 2. And then f of 2 is your 8 plus 2, and then f of 2 is 10. So that's 3. Piecewise. This one's got 3 pieces. You have as many pieces as whatever the function defines. It's all based upon the explicit domains. So for A, we want f of -4. So f of x is equal to 5 minus 2x if you're plugging in x's that are less than 0. It's equal to 5 if you're plugging in x's that are between 0 and 1, that are greater than 0 or equal to the 0, but less than the 1. And you plug it into 4x plus 1 if you're plugging in x's that are greater than or equal to it. So -4, is it in the first piece, second piece, or third piece? In the first piece. -4 is less than or equal to 0, so you plug it in here. 5 minus 2 times -4. So f of -4 is equal to 5. -2 times -4 is plus 8. So f of -4 is equal to 13. And then f of 0. So is 0 in the first piece, second piece, or third piece? Here's the equal to 0. If you have an x that's greater than or equal to the 0, well, we're plugging in 0, so that would be right here. F of x is 5. So for B, when you plug in 0, the answer is just 5. I mean, you don't have an x there. There is no x in the equation, so there's no place to put the 0 and substitute. That's a constant. No matter what I plug in for x right here, if it's between 0 and 1, f of 1/2, I get 5. F of 3, or f of 0.3, I get 5. F of 0.92, I get 5. F of 1/3, the answer is 5. From 0 to 1, the answer is always 5. It's horizontal between those two numbers. Because there's no place to put anything in for x. Because there ain't no x. And the last one we're plugging in, we're going to plug in 1. So when we plug in 1, right here, x is greater than or equal to the 1. So you plug it into this third piece. So for C, f of 1, whatever goes in, you multiply by 4. So 4 times 1. And then you have a plus 1. So f of 1 is equal to 4 plus 1. So f of 1 is 5. walk you through 53 and 55. Walk through means I'm not going to do them for you, I'm going to explain them. Okay. Now, I'm not going to pick 53 through 56 as a quiz question. I'm going to pick basically one question out of 31 through, which one did I just do right here? It's 46. No, yeah, 46. Never look before I say something I can't. Yeah. Not that I can't do, but something that I can't have. 31 through 46. I'm going to give you here's a function, plug stuff in. And then the second question is going to come out of 57 to 65. But 53, 55. Find all the values of x. So you're solving. You're going to solve for x. What does x equal? Such that f of x, the function, is equal to 0. So in other words, what could I plug in for the x that makes the function equal to 0? So you let the function equal 0. Okay. You just take this 15 minus 3x. This f of x, you want it to equal 0, so you let 15 minus 3x equal 0 and solve. Okay. It's going to give you the x-intercepts. Because when you let f of x equals 0, remember, f of x is replacing the y. So instead of f of x equals 0, what you're doing is you're letting y equals 0. And on the coordinate plane, if y is a 0, that means that point is on the x-axis. So what you're finding is, where does the graph intersect the x-axis? It's the x-intercept. Okay. If you let x equal 0, you find the y-intercept. Let y equals 0, you find an x-intercept. Now, 55, 56. Oh no, fractions. A fraction can only equal 0 when you have 0 over a number. That's when a fraction is equal to 0. A number besides 0. 0 over any other number except 0, you get 0. Well, that denominator is a 5. Tell you what, I'll do 56. Again, they give you the clue. They tell you in the directions, solve for the x such that the function f of x equals 0. So if this function is equal to 0, I'm just going to let 2x minus 3 over 7, I'm going to let that equal 0. Okay, you got fractions. Fractions means you have a denominator. Denominator means you have division, and we undo division with multiplication. I'm just going to multiply both sides by 7. 7 times, or 7 over 7 reduces. I'm left with 2x minus 3 equal to 7 times, that's a 0. So the bottom line is, if you have a rational expression, in other words, you have fractions, all you need to do is really, when's the numerator going to be a 0? Because that's what controls the fraction equaling 0, the numerator. You just have to be aware. Are there any x's in the denominator? Because that's a different story. That is completely different. Numerator. If there's no x's in the denominator, you're free to just go 2x minus 3 has to be a 0. At 3. 2x is equal to 3 divided by 2. So when x is 3 over 2, this function equals 0. And if you plug it in, f of 3 over 2. So that's 2 times x. So that would be 2 times 3 over 2 in the numerator. And then minus 3 over 7. 2 times 3 over 2. Those 2's reduce. So that's just 3 minus 3 over 7, which is 0 over 7, which is the function equals 0. When you plug in 3 over 2. Okay. It be so. Now you have to find the domain yourself. For our purposes right now, there are only 2 things, unless you have an explicitly given domain where they tell you. We're looking for, here's a function. We're not told the domain, so otherwise it's implicit. You have to figure it out. The 2 things that are going to ruin our domain. Right now, we're going to basically consider this. The domain is all real numbers. Yay, it's everything from negative infinity to infinity all the time. Unless there's trouble. Trouble messes up our domain. The 2 things that are going to cause trouble with our functions right now, 0 in the denominator, or the square root or an even root of a negative. You can't take an even root of a negative. So the 2 bad things that might happen that mess up our domains is when you get a number over 0, or you end up with an even root of a negative. That's what you have to prevent. The square root of a negative, 4th root, 6th root, any of those roots of negative. Cube root of a negative, no big deal. The answer is negative. 5th root of a negative, the answer is negative. 5th root of positive, the answer is positive. Odd roots, you can have positives or negatives. But the evens, they're a little different. So 57. F of x equals 5x squared plus 2x minus 1. Is there any way that either one of these scenarios can possibly happen when you plug in values of x? Is there any way you're going to get a 0 in the denominator or a negative in the square root if you don't even have denominators or square roots in your function? No. The only way you're going to get a 0 when you plug in an x into a function is when you have a function that has an x down below. Right here, q of t, there's a t down below. We got a problem. If I let t equal 0, 2 0 squared plus 3 over 0 squared, that would be 0 plus 3 over 0. That would be 3. That's undefined. Right here, this one, q of 0 is undefined. 0 is not in the domain. Okay. But here you have no denominator where x belongs or where x is. So this has no chance of happening. There's no even roots in this function. So this has no chance of happening. So the domain for 57 is negative infinity to infinity. And you're supposed to write it using interval notation. 59. Now there's a variable in the function down in the denominator. 4 over t. So you know we have a potential 0 in my denominator. What could I plug in for t that would make something over 0? Who's the number you cannot use in it? 0. You can't use 0. If you let t equal 0, if you go h of a 0, it will be undefined, 4 over 0. So the domain, if we use our words, would be all real numbers, except x could not equal a 0. That's one way to say it. Another way to say it would be using inequalities. X would have to be less than 0, or x would have to be bigger than 0. X just can't equal 0. So left of 0 and right of 0, you just can't equal 0. If we drew a picture of it, number line. So you have 0. And on the number line, you don't get to plug 0 in. 0 doesn't work. So there would be an open circle where the 0 is, and you would shade everything to the left, all of those answers to the left of 0, and you shade every number to the right. And that's what the number line would look like if you were going to shade the number line. That would be the domain. Everything except 0 is shaded. On the last one, it was just you shade the whole number line because it was all real numbers. But all of those are not interval notation. So interval notation. That's why I did the number line. So look at the visual. When you do interval notation, it's always left to right. Left to right. So down there forever, that's what the little arrow is pointing to the left is negative infinity. So the answers, as you go from left to right, they start from negative infinity. And when you use interval notation, remember, infinities are always parentheses. And then when you get to 0, you have a parentheses because you can't equal the 0. Something's going to go here in the middle. I'll talk about that in a second. On the right-hand side, the right-hand starts at 0, parentheses on the 0, because it doesn't equal it. And then you go all the way to the right, which is going to positive infinity. Parentheses. Now, the inequalities are joined together by the word or. Or means union. It's these numbers or these numbers. That's what you can plug in. The symbol for or mathematically, it looks like a U, but it's technically a cup. Okay, that's the symbol for or. In mathematics, some of the most important words that you're going to deal with is the word and or the word or. Or means two sets that overlap each other. You join them together. And where do the two sets intersect each other? What values, what elements are in both sets simultaneously? So and is a overlap, or is join everything together. Yes. When you use what? Bracket would be if it was equal to. So if you had, and we'll see it when we do the square root. So it is coming. But when you have equal to, then you have a solid circle, and you have greater than or equal to something. Then on an equals, you have a bracket. If it doesn't equal it, it's a parenthesis. So final answer in interval notation is this. '61, 59, 60, 61. 59, 60, 61, and then 62. S of a y is equal to 3 times y over a y plus 5. Now you got y's in the numerator and denominator, but all you are concerned with is the denominator cannot equal a 0. The last one, it was just over t. Okay, so that was simple, can't plug in 0. This time, I can plug in 0. S of 0 is 3 times 0 over 0 plus 5. So that's just 0 over 5. The answer is 0. That's fine. I can plug in 0. Because 0 doesn't make the denominator 0. That's okay. 0 makes the numerator, and that doesn't mean you get 0. What would make y plus 5 equal 0? Negative. If you plug in -5, -5 plus 5, it makes it 0. -5 is not allowed. So I would go like that. Y better not equal a -5. And that's not, too hard to just look at and figure that out just by looking. -5 plus 5, that would give me 0. If you're struggling, you go, all right, this better not equal 0. So you go y plus 5 better not equal 0. Subtract 5, subtract 5. Hey, y is better not equal -5. And it's all. So the last time the picture looked like that. This time you would have an open circle over here on the -5. When you can use everything to the left of the -5 and everything to the right of the -5. So from -infinity, and it stops at -5. And then it's joining these two sets, or union starts at -5 and goes all the way to infinity. That would be your domain. That would be, I can plug in any number from from this interval, or I can plug any number in from this interval. I just can't use -5. Okay, I'm gonna do like 60.5 and then they'll do 61. Because 61 is a cube root, 64 is a fourth root. Let's talk about square root, something simple, a square root. So this is not a homework problem, it's 60.5. So let's say we have f of x was equal to a square root of x minus 2. Now, what causes square roots to go bad? I've erased it. This is, can't have a number over 0. Bad. Can't have the square root or an even root of a negative. So inside there, x minus 2 better not equal a negative number. But this one requires a little more thought, especially when you see something like 62. This here, x minus 2 cannot equal negative. I don't know how to solve something where it just can't be negatives. So let's think. If it can't be a negative, what can it be? 0 or greater, or positives. You kind of like give away the kicker, because usually people say, if it can't be negative, it can't, and then it can be, then everybody says positive. And I say, what else can it be? And that's what people go. Start with being, it could be 0 or more. As long as it's not negative, it could be a 0 or more. This is where mathematics, they write this in. It has to be non-negative, non-negative. And I remember when I teach calculus almost every semester, students would say, why don't they just say positive? Well, positive doesn't include 0. You have positive, positive, from your perspective, positive, you have negative, 0 is neither. Okay? It's like the neutron. Electrons are negative charge, protons are positive charge, neutrons don't have a charge. 0 has no sign. So if you're taking the square root, you can take the square root of 0 or more. So this x minus 2 has to be greater than or equal to 0. That's what you can write. If you need something to solve. So now when I solve this, all of my x's, add 2, have to be greater than or equal to 2. That's my domain. The x's have to be greater than or equal to 2. Now we hadn't run up against an equals yet. If we do a number line. Now, it's a nice coincidence. When we read from left to right. Left to right. So when you solve inequality, it will really benefit you if you have x on the left-hand side of the inequality and whatever your number is you're comparing it to on the right, from left to right, x on the left, and then your number on the right. Because when you read it from left to right, x is greater than or equal to, you know exactly what direction you're going to shape. Here's 1, here's 2. Because it's equal, it can equal to 2. It would be a solid circle. And the x's that you're going to shape are greater or equal to that. Greater than is to the right of the 2. But hey, look at the direction of that inequality sign. It's pointing to the right. So I'm going to shape to the right. All of my x's are greater than or equal to the 2. So it's going to the right. That's just a nice coincidence. This is what will mess people up if they think it works all the time. If I wrote 2 is less than or equal to the x. Now the subject when we read this is the 2, not the x's. We're trying to draw a picture of all the x's. What can x equal? Here, when you read this, 2 is less than or equal to x. You're telling me about 2, not telling me about x. So when you go to graph this one, if you think you're going to shape everything to the left of 2, that's not right. That's not going to be correct. So if you ended up and you're solving it and you have x on the right-hand side instead, all you got to do is trade places. If I trade places, x and the 2, the less than or equal to is just got to flip as well. And now shade to the right because that's what it is. But now you know what those is. Interval notation, because you have an equal, 2 works. So they go from 2 equal to that, so you put a bracket. Now, you guys are just supposed to know it, but when I try to teach this to math 201 or 103 students that have never done interval notation, this is how I help them remember. You only use brackets when you have equals, and equals has that straight line at the bottom, which means you got to meet a straight line in your notation. And that's the bracket one. Greater than, this was x less than -5 or x greater than -5. If you're really sloppy, it kind of looks like a parentheses, but you don't have a straight line at the bottom. No straight line means parentheses, not a bracket. I try to give them something they can try to latch on to help them remember, because they don't try to study. And they won't remember. There's put brackets on everything. If the last thing they ever saw before the test was a bracket, they put brackets on it. Right? But try to help them figure out something. and it goes all the way to infinity. Right. So that's the domain of 60.5. So now 61. 61 and 60. 61 is a cube root. Wow. And you know, honestly, I don't mind if you need something. That's don't get this stupid or not. I'm telling you these little things that I tell the other classes because I don't know if you need it as well. Okay. Cube root x minus 4. I don't need to insult. F of x, cube root of x minus 4. Now, the domain for cube roots, for odd roots, are real numbers. You can take the cube root of negatives, positives, and zeros. Cube roots have no restrictions. So if nothing's going to cause an odd root to go bad, this x minus 4 could be anything you want, which means x could be anything you want. The domain is just negative infinity to infinity. It's all very much. Okay. F of x is the fourth root. X squared plus 3x. So that's an even root. And if you have an even root, we have a potential for bad stuff if that's an even root of a negative. So that means the inside cannot be negative. It has to be non-negative. Non-negative means x squared plus 3x has to be greater than or equal to 0, which is a completely different kind of question than the last one. The last one, it was just x. This is x squared. Okay, this is x squared. So now here's where you have to do a little bit of thinking. When you solve things that are quadratic, x squared, factor. You got a factor. Well, the first thing you do about factoring is if there's a greatest common factor, you're going to take out the greatest common factor. There's a common factor of an x. You're going to factor x out of each one of those. When you factor out x, you're dividing by x. So x squared, take out the x, you're going to have an x in the first. Plus 3x, factor out an x, you just have 3. Greater than or equal to 0. All right. Now, let's talk about the 0 part. Let's let it equal 0. This multiplication problem equals 0 if A times B is equal to 0. If the product of A times B is a 0, then A is equal to the 0 or B is the 0. One of those has to be 0. The only way to multiply and make 0, one of those factors has to be the 0. So that means either this x is a 0 or the x plus 3 is a 0. One of them, if you're gonna make a zero, one of them has to be zero, one of those factors. So then you solve each one. This one is already solved, x equals 0. Over here, subtract 3. This x would have to equal -3. So right now, those are the two x's that make 0 in inside my fourth root. If I plug in f of 0, I get the fourth root of 0 squared plus 3 times 0. 0 squared is 0, 3 times 0 is 0, 0 plus 0 is 0, fourth root is 0, perfectly fine, it's a 0. If I plug in -3, -3, so parentheses, -3 squared plus 3 times -3. So that's the fourth root of +9, 3 times -9. So that's the fourth root of 0, which is just 0. That's perfect. So those establishment zeros. But what about the in-betweens? So here's what you do. My two zeros are at 0. Now let's put it in order. -3 and 0. Number line. It's just called a simple number line test. If I was going to make a number line for the answer, equal to -3 works. Equal to 0 works. Those work. Remember what you have to worry about. You cannot get negative. It has to be a positive. So here's what you do. Pick a number and test. It's called a number line test. Give me a number to the left of -3, anything, something less than -3. Good, -4. If I use -4, that's a negative because it's -4. Inside, -4 times plus -3. -4 plus, that would be a negative. I don't care what the answer is. But you have a negative times a negative, and that would give you a positive, and is a positive greater than or equal to 0. Yes or no? So then, if one number to the left of -3 works, everything to the left of -3 is going to work. I don't care if you pick -10. -10, that's a negative. -10 plus 3, that's a negative. -10, that's going to be a positive. It's going to work. Everything to the left of -3. Then pick a number between -3 and 0. Give me something. -2. If that's a -2, that would be a negative. -2 plus 3. -2 plus 3 is a +1. So if you use -2, you have a negative times a positive, and a negative times a positive, that would be a negative. Is a negative greater than or equal to 0? Yes or no? Oh. So if -2 in between -3 and 0, if -2 doesn't work, nothing in between will work. So that interval between -3 and 0 is empty. Nothing in there works. And then pick a number greater than 0. Pick a number over here. 1. 1's fine. You don't got to be crazy to pick like 1,000 or 937.82. It's just going to be a 1. Well, if that's a 1, that's a positive. 1 plus 3, that's a positive. Positive, that would be a positive. Yep. Yep. If one number to the right, then everybody works. So that's your number line. So now the answer in interval notation, -infinity to -3, and -3 work, bracket. And then union joined together with these answers that start at 0 and go all the way to positive infinity. That's your limit. Always in the afternoon. Then last words. Okay. Now, I'm not gonna give you an X squared problem on the right one page. We just got to this on Tuesday. Let's take a quiz on that same number.
I have a quick question. So why are you graphing the equation?
What, the number line?
No, like, for example, on the X squared equals 2x.
Why am I graphing this? Or what?
Yeah, we can do
Okay. While she's formulating that, you gotta pick 67 or 69. You're supposed to. There's 67. Use a graphing utility to graph the function, find the domain or range of the function. So this time, not just domain, you gotta deal with range. If you want to choose, I would choose. And that's, I would choose that one as well, because we've already, showed you how to punch in the square root function, but some of you may not know how to punch in an absolute value in the calculator. That's going to come up often. So just looking at the picture, domain and range. So g of x is 2x plus 3. Now, be right where the calculator is. We talked a little bit about what an absolute value shape would be, especially absolute value of linear. It's an absolute value of V shape. So y equals the absolute value. Just so you can see it a little bit better here. When you go to the math button right here, math, you're going to get 4 columns. So math, we have fraction, I think that's decimal. I've never used those two. So there's your cube root, x root, okay. But if you go to the right, number functions. ABS stands for absolute value. So it's the first one on the number functions. All right. Absolute value 2x plus 3. X. What was it? 10. Now, it doesn't tell us what what to use for X and Y in the window. So I'm just going to choose a simple X and Y. And go back to my calculator. My window. I'm going to make it just a nice simple -5 to a +5 on the x-axis with an x scale of 1. Now I have no idea what the y's are going to be, so I'm going to now do a zoom fit. And the calculator will take care of figuring out what my y window will look like. So here's what it is. The window that it opened up is -5 to 5, just like I put in. So -5 to 5, but the Y minimum 0.02. So let's call that just 0 down here, and it goes all the way up to a 13. And as you can see, for this linear function, 2x plus 3 is linear. This is a V shape. Absolute value of a linear is a V shape. Now, I could have made -500 to 500. These things have arrows that go on forever. They're going to continue forever in either direction. So the first thing, domain. Domain is the x's. Look at this function. Are there any denominators where you might get 0 because you're plugging in something for x that would make 0 in a denominator? Yes or no? First of all, are there any denominators? If you ain't got no denominators, no way you're going to get 0 because you're plugging in something for x. Are there any even roots where you might get a negative because you plug in x? No, there's no roots. If you don't have any potential fractions where you plug in an x and you get a 0, or any roots where you plug in something and you get a negative and an even root, all real numbers. Domain, negative infinity to infinity. But now your range. Now, unfortunately, it doesn't really give you a good picture, especially when I use such a wide window. I'm going to narrow up my window a little bit. -5, I'm going to go from -5 to +3. And I'm actually going to take my Y minimum just for show and tell. I'm going to make that -0.5 to 7. So this is -5, this is +3, this is 0, or sorry, this is -0.5. This goes all the way to 7, but again, these things go on forever. This graph is hitting the x-axis from left to right, and then it bounces back up and it heads off in that direction. It actually touches the x-axis. It equals 0 if you plug in, okay, if you plug in -3/2, g of -3/2 is the absolute value of 2 times -3/2 plus 3. So g of -3/2 is positive times negative is going to be a negative. 2's reduced, you just get -3 plus 3. So g of -3/2, when you plug it in, you get the absolute value of 0, which is 0. So right here at -3/2 is the x-intercept. It just touches it, but it's there. So now you got to do the range. The range is, what are the y's going to be? So look at your picture. Think about inequalities. Think about less than and greater than. Less than or equal to, greater than or equal to. And that's what I always do, is I approach it from the inequality, then I convert. Are you getting any y's below here, like down here somewhere? Does the graph go down here at all? No. What's the lowest y value? Right here in the order pairs, -3/2, 0. What's the lowest, smallest y you're going to get? You're going to get 0. And then the rest of the y's are going to be greater than or equal to that 0. because they're all above the zero. So if you look at it from the perspective of the graph, and not just looking at the graph and these arrows that go left and right, but you're just looking at the y-values. All of the y's on these ordered pairs, they're either equal to 0 or 1, or they have to be bigger than 0, which means greater than 0. So the range as an inequality looks like that. If you made a number line, it would be a solid circle on the 0 and greater than the shape to the right. Which means if you translate that into interval notation, bracket 0 to infinity. And I draw the number line just because sometimes that's a nice visual before you do the interval notation. Bracket 0 to infinity. Go to the y-score. Okay. 71. Write the area A of a circle as a function of its circumference, C. So the area as a function of the circumference. So basically, when you write f as a function of x, it's f of x. When f is a function of x, that means the notation is f of the variable x. So let me say, write the area A as a function of the circumference, A of C. That's a function of the circumference. All you know is this. Area of the circle is equal to pi r squared. That's what you know. Okay. Or that's what you should know. Area of a circle is pi times the radius squared. So now your job is to convert this and change this and to somehow make it a circumference in it. Replace r with circumference. Well, you should know the formula for circumference. The circumference of a circle is pi times the diameter of the circle, or since the diameter of the circle is twice the radius, you also know that circumference is 2 pi times r. Do those ring the bell at all? So, if you want the area with respect to the circumference, instead of the area with respect to the radius, that means you have to, trade the r for c. Instead of r's, we want c. So, okay. What is r here? How do I solve for r? Divide both sides by 2 pi. Since r is being multiplied by 2 times pi, divide both sides by 2 pi, so the radius can be replaced with 2 pi into the circumference, so circumference divided by 2 pi. So I'm going to replace I'm going to let the radius be replaced by the circumference divided by 2 pi. Now, remember, pi is an actual number. It's not a variable. So it's perfectly fine to plug it in. Now it's going to be this pi times the radius squared, and I'm putting c over 2 pi in for the radius. So you got to square it. Okay, let's see if you can do this part. A is equal to AC is equal to pi times. If you square a fraction, you got to square the numerator and square the denominator. So that's going to be c squared in the numerator. When I square the denominator, I square both factors. So that's going to be 2 squared, which is 4, pi squared. 2 pi squared is 4 pi squared. And then always you simplify. The area as a function of the circumference is equal to pi over pi squared. You can reduce one of the pi's. So it's the circumference squared divided by 4 pi. And that would be the area of a circle with respect to the circumference of the circle. Okay. So now you have to choose between 73 and 75. 73. An open box of maximum volume is to be made from a square piece of material, 24 centimeters on one side, by cutting equal squares from the corners, turning the sides. So it's part A, part B, part C, part D. Or 75. A rectangle is bounded by the x-axis and a semicircle, y equals 36 squared, 36 minus x squared. As shown in the figure, write the area of the rectangle as a function of x and determine the domain of the function. 75. 7. All right. We got a 75. Best part about this, they draw picture books. A rectangle is bounded by. Bounded means basically the boundaries of the rectangle. Boundary is the x-axis, that's the bottom. Okay, and this semicircle. So if you have, basically a rectangle where the bottom is at the x-axis, it could be this wide. If it's this wide, then it would go all the way and you'd have a rectangle like this. Okay. If your rectangle went from -4 to +4, then you have a rectangle that would look like this. You could have a really short rectangle because it's almost at -6 and we go all the way like this. Okay. They're giving us this one. Write the area of the rectangle as a function of x, because x could be anything you want. If x is 1, then it's a really tall, skinny rectangle. If x is 3, then it's wider like this. In fact, it almost looks like a square, almost. Okay. So write the area of the rectangle as a function of x. Well, first of all, the area of a rectangle is equal to base times the height. That's the area of a rectangle. Let's start with what it's supposed to be. The base of this rectangle. Now, as a function of x. So we're looking for a of x. The base of this rectangle, now, just because it looks like it's at -5 over here at +5, they're not. Right here, it tells you that this ordered pair is xy, which means right here, that x value is some x. It's just some x, right? And that's what it's supposed to be because you're supposed to write the answer in terms of x. What is the entire base of this rectangle length going to be? Let's say it was 5. If that was 5, then what's the entire length? 2 times 5, 10. Because if it's 5 all the way to the right, then this is -5 over here on the left. And so the entire base would be -5 to +5. Therefore, it would be a 10. If it was here at 2, then the base would be from -2 to 2. So that would be a base of 4. So now it's not at 5, it's at x, which means over here, this side would be at the negative part of x. If one's at 4, this is -4. This is positive 1.2, this is negative 1.2. So if one is over here at positive x, on the left side, you're at negative x. So what's the total distance at the bottom? Well, if I just use this as an x, it's 2 times that x. So it's 2 times x. Okay. 2 times x. The base is 2x. Times the height. Well, in this picture, the height is this side. Here's the base, it's 2x wide, and the height is y. It's whatever the y is. You know, when you plug in 1, 36 minus 1 squared is 5, that would be square root of 35. You plug in 4, 36 minus 16, so it's going to be square root of 20. When you plug in 6, right here, at that point, 36 minus 6 squared, the height is 0 when you're at 6. You don't have a rectangle at all. So the height is whatever y is. So what's the height when you're plugging in x? It's given to you. Y, the height, is the square root of 36 minus x squared. So the area is 2x for the base times the square root of 36 minus x squared for the height. And that's it, you're done. So one. Oh, sorry, domain. Wait. Okay, domain. Well, first of all, if you have a negative, then out here, if x is negative, you would have a negative area because 2 times a negative would give you a negative, so that is. If x is 0, then you don't have any area, which means you don't have a triangle, a rectangle at all. If you put, right here, if you're exactly at x equals 0, then your rectangle is just basically that straight line straight up. You don't have a rectangle up. X can't be 0. X can't be negative. So basically, your x's have to be greater than 0, not equal to 0. Can't do that. Is there a finite limitation on x? Can that go really big? Can I plug in, 5, 6, 7, 8, 9, keep on going higher and higher and higher? What happened when I plugged in 6? What did I get? I got 0. What would I get if I plugged in 7? I get a negative. 36 minus 7 squared, 7 squared is 49, 36 minus 49, I'd be taking the square root of the negative. So I can't use anything bigger than 6. Can I use 6? I can't use 6 either because if I use 6, the height is 0, I don't have a rectangle. So the x's from here, the x's have to be smaller than a 6. So the one on the outside, if I'm going to have an actual area and an actual rectangle, this one determines I have to have x's that are greater than 0. And these x's have to be less than 6. So no equals, so that'd be an open circle on the 0. Greater than 0 goes that way. X's have to be less than 6. So open circle on the 6, less than 6 goes that way. So everything that would work would be the stuff in between. So my domain would consist of any number that's in between 0 and 6. That would be my domain. Okay. I'll tell you right now, I'll be honest with you, I hated domain questions when I was a student because no one told me that I was supposed to think about it. The way that they were explained to me is I was just supposed to know what they were. You know, you look at it going, oh yeah, the domain is whatever. Because that's whoever was teaching me was, they would just write it up, oh, the domain is this, let's move on. There was no explanation, there was no process. There was no, you need to think. I'm telling you, you need to think sometimes. It's about these different parts, you need to process. People say, what am I going to use this in the real world? Well, here's an example of something that we would do in the real world because we want to maximize area and minimize material. Whether it's a garden, basically bounded by a semicircle on a wall, or a koi pond bounded by a semicircle on a wall, or whatever. All sorts of different applications because not everything's going to be a nice semicircle on a wall. Okay. But this is the start. This comes in, I've done this problem in calculus all the time. We take it to the next level is, what is the maximum volume of that rectangle? And you actually now need to take derivatives. Next one, 81. Projectile motion. The height in feet wide of a baseball thrown by a child is negative 0.1 x squared plus 3x plus 6, where x is the horizontal distance in feet from where the ball is thrown. So if the child throws the ball 2 feet, then you plug in 2 for x, and you'll find out what is the height 2 feet away from the child. Okay. Why is it negative here? Why would you have a negative 0.1 in front of that x squared? Remember, it's telling us what the height of the ball is going to be as the ball moves forward away from the child. So, yeah, it's going to, what goes up must come down. So as you plug in certain numbers of x, it's all going to be going up, and the further away you get, eventually the y value has to get smaller because it's coming down. What goes up must come down. Okay. Will the ball fly over the glove of another child 30 feet away trying to catch the ball? Explain. Assume the child who is trying to catch the ball holds the baseball glove at a height of 5 feet. Oh yeah, pictures of stuff. So here's the kid throwing the ball. A little stick figure. Throwing the ball. Over here you got this guy trying to catch it. And he's got the mitt right here. This is 5 feet. Okay. And we want to know, is it going to go over his glove or not when this is 30 feet away? So when x equals 30, is the height going to be greater than 5 or less than 5? If it's less than 5 feet, the kid's going to catch it, we hope. If it's greater than 5, then it's going over his head. That makes sense. But that's what they're telling you. People see the word problem going, I'm out, I don't want it. What about fly over the glove, 30 feet away, x equals the feet. Let x equal 30. Y is equal to negative 0.1 times 30 squared plus 3 times 30 plus 6. So y is equal to negative 0.1 times 900 plus 90 plus 6. So y is equal to negative 90 plus 96. So y is equal to 60. Is he going to catch it or is he going to go over his head? One over his head. Evaluating a difference quotient. Difference means subtraction, 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 subtraction. So those are all subtraction problems. The difference quotient. Quotient means you got something in the denominator, you got a block, you got a block. So which one? 83 or 85? $85. I mean, they're done the same way, so let's do 85. 85's got more stuff in it. It's like a big salad on something. It's got more stuff. 85 says f of x is x squared minus x plus 1. And you're supposed to evaluate what does f of 2 plus h minus f of 2 all over h equal, as long as h does not equal 0. You're not allowed to put 0 over h. All right, so I'm going to replace this x with 2 plus h. And just for the, if you did let h equal to 0, 2 plus 0 is 2. F of 2 minus f of 2 definitely would be 0 because it's the same thing. And again, if you're plugging 0 in for h there, you got to plug 0 in for h here. So the numerator is 0, the denominator would be a 0. 0 over 0, 0. So 2 plus h goes here. 2 plus h goes in for that x. And use parentheses because whatever goes in here, you're going to square. And then you're going to subtract 2 plus h going in for that x. And because you're going to subtract, you better put it in parentheses. So the first substitution, you plug 2 plus h in for this x, and you're going to square it. 2 plus h, and you're going to square it. And then minus for this x, you're replacing with another 2 plus h. And the rest of the function is you now have a plus 1. So this right here is what f of 2 plus h looks like. Then it's minus, so it's this minus plug 2 into the function. So now you're going to plug 2 into the function. So you're now going to replace x's with a 2. And because there's 3 terms over here, don't mess up your sign. What I'm going to subtract, I want to make sure I have it in parentheses. So minus, here comes the parentheses. I'm going to plug in a 2. So 2 is going to get squared. Minus, plugging in 2. And then I have a plus 1. And then close that parentheses. In the denominator, it's an h. So this first part is f of 2 plus h, and then you have your minus. This is your f of 2. Here comes the algebra. So this equals 2 plus h squared is 4 plus 4h plus h squared. Minus 2 plus h, so you distribute the negative, minus 2 minus h. And you still have that plus 1. And then we have minus. I'm going to do what's in the parentheses first. 4 minus 2 plus 1 all over h. So yep. Now, in this first group, you have a 4 minus 2. 4 minus 2 is 2. And then 2 plus 1, that's a 3. You have a 4 times h. Okay. A 4 times h minus an h. 4 times h minus h is going to be 3h. And then you have a plus h squared. And then you still have minus. 4 minus 2 is 2. 2 plus 1 is 3. So this is minus 3. All over h. Three minus 3 cancels out. So you're left with 3h plus h squared over h. You always need to simplify if possible. So either if you factor or you separate it into individual fractions. If you're going to go to calculus, you got to use the factor. There's a common factor of h. So if you factor out the h, you get 3 plus h to the first over h. Those reduce. So this f of 2 plus h minus f of 2 all over h is 3 plus h. Unfortunately, I was doing one more step in calculus. One more step in calculus was you now take the limit and let h approach 0. If you let h approach 0, 3 plus 0 is just, I get 3. But I'm not doing calculus, you're just doing the difference function. The difference function. So anything I didn't get, but you want to see, you need to talk about. At 1.3, like I said, quiz is coming from that set of problems, and basically I'm looking at one question from substitutions 31 to the 46, and then one question from the 57 to the 66. Find the domain. With our time that we have left, we have just 15 minutes left. 1-4. Let's see what we're up against here. Okay, 1-4 is dealing with graphs, but it's also dealing with, more importantly, the words involved with a graph. The information about graphs. What do graphs tell us? So it's not necessarily graphing, but what do graphs tell us? What do they mean to us? How we use graphs? Okay. Second up here, find the domain and range of a function. Use the graph of the function f to find A, the domain, B, the function of f -1, f 2, and then C, what's the range. So just by looking at the picture, you're supposed to be able to generate all of those answers. And a lot of times, that's all you have is the data. You use the data to figure out what am I working with, what am I using as my domain, what are the set of things that you plug in, what are the set of things coming out, what are the specific things that I want to find in between inside the domain. What's happening at year 15 when I have information about year 10 through 25. So domain. So our graph on the x-axis starts here at x equals -1, and the most important thing is your graph is giving you solid circle, closed circle, closed dot. And then as you go from left to right, domain is the x. It goes up, it comes down. And right there, okay, it's got an open dot. So that means when you get to x equals 4, you don't actually plug the 4 in. 4 is not part of what's being used. It goes infinitely close to 4, 3.9, 3.99, 3.999, 3.999, but not 4. So the domain would be everything from -1 with a closed interval bracket all the way to 4 with an open interval or parentheses and everything in between. Okay. Then what is the answer? What does f of -1 equal? So they want to know, remember, you're plugging in -1 as the x coordinate. You're basically trying to figure out what's the y that goes with it. So go right here, when you're plugging in -1, oh look, they tell you the order pair. So f of negative must equal -5. Okay? If you have the ordered pair, you have the answer to the function and vice versa. If you have the answer to it as a function, you know what it is as an ordered pair. What about f of 2? When x is 2, they tell you there's an ordered pair right there at 2, 4. So when you plug 2 into the function, the answer is a 4. Now, if they said, what's f of 3? That's kind of like an elephant or rhinoceros. What do you do when you cross an elephant or rhinoceros? I don't know. Because there's no dot specifically telling us what it equals. You could guess, but you'd be wrong. Because you're not explicitly told. Okay. And then the range. The range is about who? The y's. Domain is the x's, range is the y's. So what is the smallest y in that picture? -5. Look at the y-axis. This is your lowest y value. There's no y's down here because it doesn't have an arrow. It's got a dot. It stops. And then the y's go up, and it reaches the highest point up here at 4, and then it comes back down. And yeah, there's an open circle. This y over here does not actually equal to 0, but does the y over here equal 0? Yes or no? Yeah, because there's no open circle right there. Just because y doesn't equal 0 over here, from here to here, there's no open circle. That means the y is using everything from -5 all the way up to +4. The y is going all the way in between -5 and +4. It's in between those two numbers. Does it actually equal those two numbers? Yeah, because it's a solid dot here, closed dot, and that's a closed dot up there. So the interval would be -5 to 4. That's your range. Okay. So interpretation of the graph. Now, if you just have a function, how do you get the domain and the range if all you have is the function and you don't have a picture? Well, you can always make your own picture. You should be able to do this, especially if you're going to be ready for Thursday's quiz. Domain. That's a square root. You can't take the square root. Bad stuff will happen if you try to take square root of domain. So the x minus 4 has to be greater than 0, but it could also equal 0. So the domain would be all the x's that are greater than or equal to a 4, which means they start at 4 with a close or a bracket, and they go all the way to infinity. Okay, I know what the domain is. Range. Well, if the first x I can plug in is a 4, 4 minus 4 is 0. The y that comes out is 0. Now let's think. When you take a square root, would you ever get a negative answer? No. If you get this one, x squared equals 100, and you take the square root of both sides, you want every single possible answer for x that makes this work. So don't forget to put plus and minus. X could be +10 or -10 if you're solving an equation. But when you're just evaluating the square root, it's always positive. Any even root, always positive. This would never equal anything that would be negative. It can equal 0, So the range, when you think about it, the y's would have to be greater than or equal to 0 out of that square root. Okay, that means bracket on the 0, and it goes all the way to infinity, is my range. Okay, there's my domain range. Now, we talked about the vertical line test. A function, okay, you have, by definition, every set of ordered pairs called relations. You got a set of ordered pairs, they're all relations, always a relation. Special sets of ordered pairs, where the x does not repeat itself, where x does not have two different y's. You plug in 5 and you get 7, plug in 5 later on, you get 10. You can't have that. X cannot happen twice. Special sets, special relations where x doesn't repeat, those are functions. Which means you can't have one x value above another x value. That violates the fact that, the definition of function. The vertical line test, we have a picture, a set of points in a coordinate plane is the graph of y as a function of x if and only if no vertical line intersects the graph at more than one point. So if you drag a vertical line, or in this case, maybe your finger across a picture, if the vertical line only ever intersects that picture once at a time, that would be a function. If it ever can intersect twice, not a function. So like this first one. Obviously not a function. When x is 3, you got a point up there, you got a point up there, not a function. But as you go from here to here, a vertical line never enters, so that passes the vertical line test. That is a function. Okay. So make sure you have your finger. I'm not going to dwell on this a lot. I'm not going to, when I teach calculus, I make students regurgitate these definitions back to me, because if you're taking calculus, you have to be able to speak the language. But the whole idea of why we do calculus is to understand slope. When does a function increase? When does it decrease? When is it constant? Increasing means goes up. Decreasing means goes down. But how do you define that? Because that really isn't a mathematical definition. So that's something that we're going to get into. Your most important idea or job is going to be, can you figure out the intervals by looking at a picture where something's increasing or decreasing? And then we get into relative maximums and minimums, which is what drives life. Maxing out things and minimizing things. And then that'll be on Thursday. And then it's time to do our steps. Also on Thursday, we'll be doing our step functions. I'll show you how to use the calculator to use step functions. So, ready for the quiz? Make sure you finish up 1.3. Let me hit roll. Josh Aguilar. Here. Yasmin. Charles. Okay, Francisco. Luis. Here. Marcelino. David. Daniela. Alyssa. Alma. Ryan. And Casey. I'm sorry. The glasses are all over the place.
No, that's actually, I normally go by.
Oh, do you? Okay.
My-
Oh.
boy.